Okay, so question 1 asks you for volume of gas collected over time. So if you remember, volume of gas will always be increasing and then it will come to a stop. So answer is D. Okay, question 2. It says here excess of magnesium carbonate. So when it says excess, it means too much. So there's a lot of magnesium carbonate. And then they talk about it finally stopping. So remember, every time a reaction stops, it's because the reactant that is not in excess is used up. So in this case, sulfuric acid is the one that is not in excess. So sulfuric acid is completely used up. So A. Okay, next question 3. It talks about the rate of production of hydrogen for the first 40 seconds. So the rate of production or the speed of reaction is the same thing. It is the volume of gas produced over the time taken. So if it's 40 seconds, please always use a ruler to make sure you don't lose marks because you drew the line wrongly. So this is 32. So 32 cubic centimeters divided by 40 seconds. Your answer should be C, 0.8. Okay, so be careful that you find the correct volume of gas. Okay, this next question says zinc carbonate reacting with hydrochloric acid. So this is a metal carbonate reacting with an acid. What you should get is salt water carbon dioxide gas. So we write it down. Zinc carbonate reacts with hydrochloric acid. So what is my salt name? So my salt name would be zinc, the metal, and followed by chloride from hydrochloric acid. We'll get water and we'll get carbon dioxide gas. So now we write the chemical formulas. So charges are balanced, so ZnCO3. Hydrochloric acid based on memory HCl. Charges are not balanced, we need 2Cl to balance it. Water H2O. So we write down the chemical formulas. And then now you check if the equation is balanced. So by counting the equation is balanced, we talk about the state symbol. So zinc carbonate, they say lumps of zinc carbonate. So it means it's solid. Also, all carbonates are insoluble except spar. Hydrochloric acid is aqueous because it's acid. All chloride is soluble except for silver and lead. So zinc chloride will be AQ. Water will be small letter L. Carbon dioxide G. Okay, part B. Which reagent is in excess? So when you look at the graph, what's happening here is this graph is a graph showing you the mass of zinc carbonate. So the mass is decreasing because it's reacting. But at the end of the experiment, you realize there's still zinc carbonate left over, which means zinc carbonate must be the one in excess because there is zinc carbonate left at the end of the experiment. So what was used up would be hydrochloric acid that was used up. So this is the explanation. Some of you were given the mark that says hydrochloric acid was used up to explain. Because this question is not very clear, so we have given you the mark as well. Okay, for part C, this is something that you have not tried to explain. So they ask you to compare the gradient at first, 7, and 14. So I'll draw the line at the first. I'll draw the line at 7 so that I know where I'm looking at. And then I'll even draw a slight tangent, this is called a tangent, just to see how steep the gradient really is by comparing these lines at the gradient. So from this red lines, you can tell that first minute is steep. Okay, so let me fold the paper so that you can see the graph at the same time while I'm answering the question. So first we say that at the first minute, we explain how the gradient looks like. So the gradient is steep. Then we have to explain why the gradient is steep. So most of you have one of these missing parts. So it was a steep gradient as the reaction is fast, which is why there's a steep gradient, because it's fast. Okay, then we move on. The gradient is less steep. Why is the gradient less steep? What's happening to the speed of reaction? So the reaction is slowing down. And it's slowing down because the amount of acid is reducing. So due to acid being reduced. Okay, and at the 14th minute, the gradient is 0. Means that there is no more curve, it's a straight line. So the gradient is 0. As the reaction stops. So why do you think the reaction would stop? Again, it's back to the acid being used up. The reactant that is not in excess is being used up. Okay, next part D, rate of reaction. So the earlier part, you saw that we use volume of gas, but here we do not have the volume of gas. So here what we use is the change in mass. How much mass was lost? So at the start, there was 4 grams of zinc carbonate. But at the end, again, use your ruler. At 4 minutes, at 4 minutes, use your ruler, and you realize that at the 4-minute mark, the amount of zinc carbonate left is 1.75 grams. So what is the change in mass? The change in mass is 4 minus 1.75. And over the time is 4 minutes. So if you press the calculator, there are 4 decimal places. So what we do, we change it to 3 significant figures. So 0.563. And remember to put your units that I missed out, gram per minute. Okay, we are moving a bit faster now. So volume of gas collected and measured means it must be gas strange. So you really need to be able to draw this correctly. Use a ruler to draw, remember, and pencil so that you can erase. Okay, and the last part is sketching the graph and volume of gas over time, and the time in the question says in seconds. So remember, volume of gas is always this shape, You can even refer to your MCQ in front and you get this shape. Okay, but what is missing is you need to write the labels. So volume of gas, and volume of gas is usually in cubic centimeters. And the time in this experiment is seconds.